In this section, we'll look into the meaning of specific heat capacity and the method of measure the specific capacity of water. In example 3, we have compared the heat capacity of the water in a swimming pool and that in a glass of water. We know that the heat capacity of the water in a swimming pool is much larger. It is because the mass of the water in a swimming pool is much larger. In both cases, we talk about the water, but the heat capacity of the water in the swimming pool is much larger. So, if we want to compare the amount of energy to heat up an object, we should also consider the mass. Instead of consider the whole object, we only consider 1 kg of the object. Now, let's have a quick review of the definition of heat capacity. The heat capacity of an object is the energy needed to heat up the object by 1 degree Celsius. Do you remember the equation and the unit for the heat capacity? The definition of specific capacity is very similar to that of heat capacity. The specific capacity of an object is the energy needed to heat up 1 kg of the object by 1 degree Celsius. So the difference is only the 1 kg. Well, because we look at the energy needed to heat up an object per 1 kg, so when we look at the equation of specific capacity, the energy should be divided by the mass m. In doing so, the unit of specific capacity should look like this. Make sure you understand the meaning of all symbols. E stands for the energy transferred to the object. M stands for the mass of the object. Delta T stands for the temperature change of the object. Let's look at a simple example. In example 4, we're asked to find the energy needed to raise the temperature of a 5 kg of aluminum from 20 degrees Celsius to 100 degrees Celsius. It's given that the specific capacity of aluminum is 900 J per kg per degree Celsius. Well, we start from the equation of specific capacity. If we rearrange the position of the symbol, we'll get an equation like this. E is the energy needed and is the unknown which has to be found. M is the mass of the aluminum, which is 5. C is the specific capacity of aluminum, which is 900. Delta T is the temperature change, which is 80. So after we put all the value into the equation, we'll get something like this. So the energy needed is 360 kilojoule. So if we want to raise the temperature of a 5 kg aluminum from 20 degrees Celsius to 100 degrees Celsius, we need 360 kilojoule. We will look at the meaning of specific capacity of aluminum, 900 J per kg per degree Celsius. In fact, it means that if we want to raise the temperature of 1 kg of aluminum by 1 degree Celsius, we need 900 J.